Hey there. In this lecture, I want to talk about what happens when threads share common data. Okay, the state of a particular variable can change, right, during the flow of the application. But what happens when two threads are working with that variable's state? Right, things are going to change. And so if two threads are accessing the same data at the same time, or seemingly so at the same time, things are going to get a little hairy, and that's where multi-threading becomes more challenging. So I'm going to show you how to handle those sorts of situations by using synchronization. I'm going to teach you how to synchronize your threads when working with data that is shared across the application, across two or multiple threads. So let's get started. I have the application class. I got rid of the previous code, and we have the main method in here. And for this example, I'm going to create a class called sequence. So go to right-click, new class, and we're going to just call it sequence. And just hit finish. And this class is going to maintain numeric sequence. It's going to have a method in here. We can just say it's going to be a public int get next. And this method is going to return an integer incremented to the next value. So it's just going to return value, but right before it, it's going to increment value. So we're going to do value plus plus, right? And what is value? That's just going to be a member variable in this class. So we're going to say private int value, and it's going to initialize to 0 first, okay? So when we create an instance, of sequence, that instance is going to have value to be 0, and then when we invoke the get next on that instance, it's going to basically increment value and return it. So this is capable of maintaining the sequence 1, 2, 3, 4, and so on. So back in the application class, in the main method, let's create an instance of sequence. And if I was to have a for loop, let's just initialize the I variable to 0. And as long as I is less than 100, we're going to continue to increment I. And in the body of this for loop, I'm just going to do sequence dot get next. All right, and I'm going to print out whatever this equals. So it's going to be sysout the value of sequence dot get next. All right, and this, of course, is going to just print from 1 to 100. So let's give it a go. Let's hit play. And there we go. It printed out 100 at the end, and all the way to the top, it started from 1. And as you can see, the numbers are all in order, right? We don't have any repeats. There's no problems here. You can count all these numbers, and they're going to be perfectly sequential. But what happens when we access this state of the object here, when we access this value variable with two threads? When one thread runs the get next method, it's natural to think that, it's going to increment value and then return value. So it's going to be 1, and then the next thread sees value to be 2, and the next thread sees value to be 3, and so on. But in reality, that's not how it works in multi-threading. This method is not thread safe, meaning the way we expect this to work, it's not going to work in multi-threaded programs. It's not considered thread safe. I'll show you what I mean, and then I'll explain to you later why exactly this happens. So let's create a class outside of this application class. Out here, I'm going to create another class, and we'll call it worker. And it's going to extend the thread class. So this worker is a thread, and it's going to be given a constructor. And what it takes as an argument to the constructor is the particular sequence object that we want to iterate over, okay? And I'll have a member variable in this class. We'll just call it sequence is equal to null. That's when the object is initialized. It's going to be initialized to null unless we use the constructor. So the instance of sequence that's passed into the constructor of worker is going to be assigned to the member variable here in worker, right? Typical object orientation. So we're going to do this dot sequence is equal to the sequence object that's passed in to the constructor of worker. So now we just need to override the run method, right? This is a thread, so we need to override the run method. So it's going to be public void run, and I'm just going to define the for loop. So I'm going to copy this code right here, and I'm not only going to print out the next value, but I'm also going to print out which thread is running this particular line. So we could do thread, like I showed you in previous lesson, thread.currentThread.getName. All right, we'll stick with the default naming convention of threads, which is going to be, thread 0, 1, 2, 3, and so on. And I'm also going to put some characters here. We'll just say this particular thread got value, and with a space, this is going to be the particular value of the sequence. And right after this line, I also want the thread to sleep a little bit. So we're going to do thread.sleep. And we're going to sleep it for half a second, so that's 500 milliseconds. And notice that it's going to ask us to surround this with a try and catch, because an interrupted exception can happen when the thread is trying to sleep. So we're just going to surround that with try catch, and we'll just get rid of this comment here. And that's our run method. So we've defined a thread called worker. We're going to create an instance of worker and tell it to start. And we're going to do that in the main method. Now, this for loop, that was just an example that I was presenting, what happens in the main thread. And you saw that the numbers were being printed sequentially, right, without any gaps or anything. So that was working as expected in the main thread. But now let's see when we create two worker threads operating on the same object, which is the sequence object. Take a guess as to what's going to happen. So I'll create the first worker, and I'll just call it worker1 is equal to new worker. And the argument to this worker is going to be the particular sequence that we've instantiated up here. And I'm going to do the same exact thing for the second worker down here. And this is going to be called worker2. So of course, at this point, these workers are just, instances of the thread, but the thread has not been started yet. So let's start these babies. We're going to do worker1.start. Whoops, not dot sequence, but start. And we're going to do the same thing for worker2. So now let me hit run, and you'll notice what is printed to the screen. Again, we're using this sequence object. We expect this guy to just print the next available number. It's going to increment and print the next number, right? But you'll notice that that's not exactly how it works with multi-threading. So let's hit play. And pretty soon, you'll notice that we've got problems here. The numbers are repeating. So let me go to the top. Thread 0 got value 2, right? Thread 1 got value 1. Thread 0 got value 4. Thread 1 got value 3. And pretty soon, you'll see that we've got repeats as well. Thread 1 got 7, and thread 0 also got 7. All right, thread 1 got value 8, and thread 0 got value 8 as well. So it's not really incrementing as we expect it to. All right, we've got repeats here. So why is this? Now, as we've seen before, we could have interleaving with threads, but how exactly is it printing out the number 12 twice or the number 13 twice? The reason is this. At any given point in time, the processor can only give control to one thread, okay? And by control, I mean the ability to execute code. So if we have a single threaded program, that means we just have, the program in the main method, right? The main thread. And what is the main thread going to do? It's just going to execute line by line, whatever it needs to do. But if we have two threads, then the processor needs to give control to both of those threads, okay? The processor is only capable of handling over the control to one thread at a time. One processor cannot give control to two threads at the same time. That's just not how it works. The processor is capable of handing over the control to one thread at a time. So what this means is if you've got a program that's involving 10 threads, the processor is going to allocate execution to each one of those threads one at a time. Okay, it's going to tell one thread to, hey, you can process a little bit of code, and then when that thread kind of slows down, it's going to pause it, move to the next thread, give that thread the opportunity to run a little bit of code, and then take away that opportunity and give it to some other thread. So the processor is handling the ability, handling the control over to the thread to run some code, and then it takes away that control and gives it to another thread, and then that thread does, some processing, and then the processor takes away that control from the second thread and hands it over to the third thread, and so on, right? So in this case, we've got two threads, so the processor is, of course, only capable of processing, of handling control to one thread at a time. So the processor is going to hand it to thread 1. The thread 1 is going to do a little bit of processing, right, executing instructions, but then before it finishes, the processor might tell it to, hey, hold your horses right here. I'm going to hand this control over to the other thread. And so thread 2 is going to process some instructions, and before that's finished, the processor is going to say, hey, hold on tight. I'm taking away your control for a minute. I'm just going to hand it over to this other thread. And so there's this back and forth giving of control to the thread to process, to run the code. And what often happens is midway through the thread execution, the thread may be told to pause or to hold so that another thread is given an opportunity. And this concept is referred to as preemptive scheduling. So you can, of course, imagine where this can be a problem. If we are sharing data across threads, we're going to have all kinds of inconsistencies. One thread may be done reading the data, the other thread may still need to read that data, right? So there's going to be a difference between where a particular thread is compared to another thread in terms of reading or writing to that shared data. And that's a problem. But the reality is the processor is controlling the entire flow, and it's handing the control over to the thread to say, okay, do a little bit of work, then give me back the control so that I can give it to another thread. Okay, and this is how the control is basically shifted across the threads, and eventually all the threads complete. So if we look at this example, taking that into consideration, this sequence, it's not thread safe, because on this particular line number 8, when a thread is handed the control, it's going to tabulate whatever this is. And this is not just one step. This is actually 3 steps. That's basically the same thing as this. Right? This is exactly what is going on. So what the thread is going to do is it's going to first read the value, whatever the current value is. And let's say the current value is, for example, 3. And after it reads that value, it may be told to pause, right? And the control may be given to another thread. Okay? And that other thread will read this value and say, oh, it's 3. So it's going to add 1 to it, and then the value is going to be 4. So the second thread is going to return the value 4. And then when the control is handed back to the first thread had read this value to be 3 as well. Okay, so it's going to add 1 to it, and it's going to be equal to 4. And that's why both threads will return the value 4. This is not thread safe because this value variable is a shared data. It's being shared across multiple threads, and those threads could pause right in the middle of processing. All right. So again, I don't mean to beat a dead horse here, but I'm going to repeat myself because this is important and I want you to thoroughly understand this. So the first thread may see this value as 3 and be told to pause. Okay. And the second thread may come in and read this value to be 3 as well and be told to pause. So when control is given back to the first thread, it's going to tabulate this to 4, and then the control may be given back to the second thread, and that's also going to give the value 4. And so that is why we see these repeats here. Okay. So this, in essence, this line number 8 is 3 steps, right? It reads the value, adds 1 to it, and then writes the value back to the variable value. This code is not thread safe, meaning what we intend for this to do, we intend this to maintain a sequence at all costs, but it's unable to do that. It can do it in a single threaded environment, but it cannot do it in a multi-threaded environment. So you might be wondering, how do we make this thread safe? Meaning it will work as expected even in a multi-threaded environment. How do we make this thread safe? It all comes down to this concept known as atomicity. And what that means is all or nothing. We either want this entire line to run, or we don't want this entire line to run at all. When we have multi-threaded programs, parts of this line can run, and right in the middle, that thread could be told to pause, and another thread may take over and do the same work again. And we don't want that thread to be paused. We want this whole line to be run completely, all or nothing. Okay, either do the whole thing or don't do it at all. Right? That's what atomicity means. So this entire line together is useful. In parts, it's actually quite detrimental. We don't want it to be done in parts. So to make this atomic, there is a keyword in Java known as synchronized. And so the way that works is we can define a synchronized block. So if I do synchronized, and we need to surround the code that we want synchronized. So inside of these brackets, we need to basically move both of these lines, the calculation of the next value as well as the return clause for that value. Okay, and for synchronized, we need to actually specify the object, and that object is going to be called this. Okay, and that's what you do. You basically, put parentheses around it, and you use this to specify that this is the object. The instance of sequence that is being used in the thread is the particular object that's going to be synchronized. And basically what this means is that when code inside of this synchronized block, when it's running, when it's inside of here, it's not going to pause, right? The thread is not going to pause and let another thread come in, okay? This thread that's going to be running this code, as soon as it enters this synchronized block, it's going to stay in there and do all or nothing. It's going to go in there, it's going to execute all of the lines without exiting, okay, without pausing, so to speak, or sleeping or yielding. It's going to complete everything in the synchronized block. So this is actually referred to as a lock. The thread acquires a lock on this particular object and says, no one's allowed to enter into this. No other thread is going to be handed the control until I'm done executing what's inside of this synchronized block. Okay, and it's important to have both of these lines, not just the incrementing line in the synchronized block. We also need to return the updated value. All right, so that whatever thread comes up next gets the latest value, is able to read the latest value when the get next method is invoked. Okay, so now let's save this file and press run. And notice that now we're getting unique numbers. Okay, let's let this run for a minute, and you're going to see that there's no repeats. I'm certain that you will not find a repeated number in this case because the code is actually now synchronized. Once a thread enters this block, it's going to execute everything inside of this. All other threads are going to have to wait until the executing thread that's inside of this lock is done running all of the code. So this synchronized block guarantees atomicity, all or nothing. The thread that's acquired the lock, that's running these lines of code inside of the synchronized block will not be put on hold, right? That thread is going to continue until it's done and exits this synchronized block. Only then the other threads that, may be waiting will get an opportunity to enter this block. So any other thread that comes along is going to have the most recent updated value when they call the get next method. Okay, so let's let this finish. I'm going to scroll down, and we should be done at 200. And there we go. Now you might be noticing that the order of these numbers is different, right? So thread 1 picked up the value 2, whereas thread 0 picked up the value 1. So this is just a difference in which thread executed this particular print statement first. Okay, so going back into this application, when we are about to print this piece of code where we specify where the thread's name is specified and then it prints this get next, this piece is synchronized, right? So it's always going to get the latest value, but the printing of this line, one thread may print that first, whereas another thread may print it second. So here thread 1 beat it to the punch and printed its value first, whereas thread 0 got a chance to print it second. But you'll notice that the numbers are all unique. You won't find a repeated number, okay? Now going back to sequence, there's another thing you can do here. Rather than surrounding all of the code inside of this method in the synchronized block, there's a shorter way of doing this. Let me get rid of this synchronized block and actually add synchronized to the method definition. I could do public synchronized int get next. Okay, so now the method signature has been given the synchronized keyword. So whatever happens inside of this method, as soon as this method is invoked, the thread will acquire a lock and stay within this method until everything is executed. It's not going to hold or pause and let some other thread come in. It's going to acquire that lock. The thread is going to execute everything inside of this. It works essentially exactly the same way as having the synchronized block within this method call. We can actually just put synchronized in the method signature and it will do virtually the same thing. So let's go back to the application, hit play, and you'll notice that it's going to work exactly the same. We won't see any issues. We won't see any repeats in the numbers, okay? All right, so we covered a lot of ground in this lesson. We're going to continue on this topic in the next lesson, so stay tuned. I'll see you soon.